Hi everyone, we're looking at our next section today on problem solving with trigonometric ratios. So we'll be taking all of our ratios, the sine theta, cos theta, and tangent theta, and we'll be applying them to world life or real life situations. Okay, so the first thing we need to look at is angles of elevation and angles of depression. So with respect to the observer, we can either be looking at things at a level of elevation, or we can looking at things as a level of depression. And that is always going to be with respect to the horizontal. So if I am looking upwards, I'd be looking at an angle of elevation with respect to the horizontal. And if I was looking downwards with respect to the horizontal, I would be looking at an angle of depression. Now, let's get to the first problem. It says, determine the height of the tree that casts a shadow of 27.6 meters when the sun is at an angle of 35 degrees. So the first thing I would write down very quickly is just SOHCAHTOA, so you know what your ratios are. And I would say, okay, well, I'm looking to see how high my tree is. And so here's my tree. And I know that the tree casts a shadow of 27.6 meters when the sun is at an angle of 35. Well, the sun at an angle of 35 degrees is going to be with respect to the horizontal or to the ground, so that I know that this angle here must be 35 degrees with respect to the horizontal. And the shadow that's being cast is not going to be the hypotenuse, but it's definitely going to be the shadow that's cast on the ground. That's going to be 27.6. So it'll be the distance from the observer, and which would be over here. Here would be your observer, and the base of the tree. And that would be a distance of 27.6. So if I now want to know what the height is of the tree from the point of view of the 35-degree angle, well, with respect to that, I have the opposite side and I have the adjacent side. So that opposite over adjacent would be tangent, so that I can say that the tangent of 35 degrees is going to equal the height divided by 27.6. And therefore, we can say that 27.6 times the tangent of 35 degrees is equal to the height. And therefore, we have that it's going to be, when we multiply that out, and we might as well multiply it out here with our calculators. Oops. We'll have 27.6 multiplied by the tangent of 35, close our parentheses, and we get 19.3. So therefore the height is going to be 19.3 meters. And again, we want our answers always to three significant figures, or we want them exact or accurate. Okay? So that's our first question done. Let's take a look at the next one. The next one says you're standing on a coastal cliff that is 400 meters high, and you have to look down from the horizontal to see a boat. So you're up here, we're up here, and it's 35 degrees looking down with respect to the horizontal. So the angle is not inside the triangle, but it's on the external part, on the outside of the triangle, because you're looking 35 degrees down with respect to the horizontal. And so you're standing up here, and the cliff is 400 meters high, and we want to know how far out our boat is. So here's our little boat. There's a little sailboat in the water, and we want to know how far out is it. So we're trying to figure out what the distance is out here. Okay, so we can take a look at this from two different points of view. So the first one would definitely be, well, if this angle that we have 35 degrees if this is 35 degrees here, then with respect to the horizontal here, or the base of the triangle, this must also be 35 degrees. So technically, I could then say, using within the triangle, I could say, well, with respect to 35 degrees, I have the opposite and the adjacent, and we're using, again, TOA of SOHCAHTOA. Okay? So that I could say the tangent of 35 degrees is equal to 400 over d, and I end up getting that d would equal to 400 divided by the tangent of 35 degrees, and I can get my answer from there, where I would have 571. So I get approximately 571 meters. So there's a distance of approximately 571 meters from the base of the cliff to the boat. All right, so that would be one method that I could adopt. The second method that I could adopt would be, well, if I know that this entire angle is 90 degrees up here from the from the observation point, and I know that the angle of depression is 35, then that means that the angle inside the triangle has to be 55. 55 and 35 would make 90. All right, so instead of using the 35-degree angle, I could technically be using the 55-degree angle as my point of reference. So that I would say, so I'm just going to erase the red part here, okay, except for the angle. I'll leave that. And I could say, well, with respect to the 55 degrees, it's opposite over adjacent still. So it would be the tangent of 55 would equal d over 400, and that would give me 400 tan of 55 is equal to d. Therefore, d is going to equal, and it should be exactly the same thing, approximately 571 meters. Okay, let's take a look at some other examples. So we have this example here, which is which I would say is far more complicated than the previous two examples. So the example says that an airplane is flying. It says that an airplane is flying at 10,000 meters at an angle of elevation of 54. So here is our 10,000 meters, the height, and our angle of elevation is 54. So it's right there, the 54. Okay? And to an observer on the ground. So the observer on the ground is seeing the plane initially here at 54 degrees. So this is the initial amount. This is the initial spot where it's found. Now, if we know that 20 seconds go by, the angle of elevation now changes. So we went from an angle of elevation being like this. So it went from being like this, and then 20 seconds later of 54, and then 20 seconds later, the angle of elevation went to this. So I've just shown you more or less what's gone on. So it was 54 here, and then it went to 42 here. And this is in the 20 seconds that passed. All right. It asks you to determine the constant speed of the plane. Okay. So given this piece of information, so we're going to do a couple of things. So since the airplane is flying at 10,000 meters at an angle of elevation of 54, and 20 seconds later the angle of elevation has changed, that means that a certain distance has been traveled in those 20 seconds. So we're going to find what that distance is that's been traveled in 20 seconds. And once we have found the distance that's been traveled in 20 seconds, then what we can do is that we can then divide that distance by the time in order to find what the constant speed is. Because remember that distance is equal to speed times time. And if I am now looking at the constant speed, the distance divided by the time should equal my speed. Okay? So let's start out by writing out, we're going to write out two different equations. So let's start out with the information that's been given to us. So we know that the distance here, the first distance, let's do the first distance A. We know that the first distance A is this, and we know that the height is this. so that it's going to be A, and it's going to be 54 degrees, and we know that the height is 10,000 meters. Okay, so if I look at the distance that's being traveled, I'm going to find my distance first from the beginning to the end of A, then I'm going to find my distance with A plus B, and then subtract those two distances to find the difference in the distances in those 20 seconds that it changed. Okay, so I will start off by saying the tangent of 54 degrees, the tangent of 54 degrees is equal to 10,000 divided by A. All right, so that's my first one. So that I can say that 10,000, so using my calculator, I'm going to work this out very quickly. With my calculator, I will say 10,000 divided by the tangent of 54 should tell me that my distance is 7,265. So the distance A is 7,265. So A is equal to 10,000 divided by tan of 54, which is 7,265. And we're going to say meters. Okay, so that's the first piece of information that we have. The second piece of information now we're going to get is, well, we have to figure out what the entire distance was with the second triangle. So this would be A plus B together. Okay? But the angle that we're looking at now is no longer 54 degrees, but it's going to be 42. So again, the height is still 10,000 because that hasn't changed. But now we're going to say that the tangent of 42 degrees is equal to 10,000 divided by A plus B. Now, we'll say that A plus B is equal to 10,000 over the tangent of 42. And because we are trying to figure out what the value of A plus B is, and we know that A is going to be the value of A is 7,265. Then we have 7,265 plus B is equal to 10,000 over the tangent of 42. So I'm going to now calculate using my GDC. So I'm just going to move this over so we can see. We're going to move this, and we're going to say then that 10,000 divided by the tangent of 42, oops, I just put in 43, 42, is equal to 11,106. So that I will have 11,000, sorry, I just forgot what I just said, 11,000, I think it was 106, okay. So that I have 7,265 plus B is equal to 11,106. So that my value of B is going to be 11,106 minus 7,265. So when I calculate the difference, 11,106 minus 7,265, I end up getting B equaling, so my value of B equals 3,841. Okay, so I now know that I've got 3,841. Now, 3,841 is the distance that's traveled, in 20 seconds. But I don't want to know what the distance is traveled in 20 seconds, but I want to know what the distance traveled was in 1 second. So that I will do 3,841, and I will divide that by 20, and get an answer of approximately 192. All right, but this is calculated. Now let me just go back for a second. This is calculated in meters. So this would be 192 meters per second. If we wanted to know what this would be, so to swap this into kilometers per hour, because we normally don't measure in meters per second a speed, then I would say 192 meters per second, and I'm trying to get this into kilometers per hour. So that means that there are, in 1 kilometer, there are 1,000 meters. So now I can exclude the meters and meters here. And in order to get to seconds, then in order to get, to hours as opposed to seconds, then I would have to say there are 3,600 seconds in an hour, so that I can now cancel out my seconds, and so I've got 192 times 3,600, and that'll be divided by 1,000, and that would be in kilometers per hour. So when I do 192, I multiply by 3,600 and divide by 1,000, I end up getting 691.2 kilometers per hour. And changing this into 3 significant figures, it would be approximately 691 kilometers per hour. And that would be our final product here. So this one definitely required a little more work in it. All right, I'm going to give you one last question to look at, and this question is, again, not particularly easy, but doable. Okay, so let's take a look at what the question says. It says that when an extension ladder is resting against a wall, it reaches 4 meters up the wall. So here it is, 4 meters up the wall. Okay, this is the 4 meters up the wall. And the ladder is extended a further 0.7 meters without moving the foot of the ladder, and it now rests against the wall 1 meter further up. So we know that the total length is 5 meters now from the bottom or from the ground. What they want us to find is the length of the extended ladder. So we're looking to find what the hypotenuse is. All right. And then they want us to find the increase in the angle that the ladder makes with the ground now that the ladder is extended. All right, so let's take a look at the information that we've got. So I'm already pretty much set here in that I know I'm going to be comparing one triangle to another in a certain sense. And the one thing that we know that is common to both of these is the distance, or the distance from the base of the ladder to the base of the ladder to the building. So I can call that, let's say I can call that, I don't know, maybe I'll call it Y. All right. So the piece of information that I can do here, that I can get, is that I've got x plus 0.7. I know that the height here is 5, and this is my y, the distance from the base of the ladder to the wall. So I could really use the Pythagorean theorem here and say y squared plus 5 squared is equal to x plus 0.7 squared. Okay? And I could also say that y squared is really equal to, in the smaller red triangle, it's going to be equal to y squared, not equal to, sorry, but y squared plus 4 squared has to equal x squared. Now, do we all agree, I hope we all agree here, that the y and the y are the same, so that if I isolated for y in both of these equations, I would get y squared, I could make the two y's equal to each other, so that I would get, I could say that 25 is equal to, and then here I would FOIL this, so it would go to x squared plus 1.4x plus 0.49. Okay, so that would be my first equation, and that would be y squared plus 25 equals, and that would be my first equation. My second equation would be y squared is equal to 16 plus 16 equals x squared. And now I'm going to isolate for y squared in both of these equations, because I don't need to know what the distance is from the base of the ladder to the wall, because it's going to be the same distance for both triangles. So I'll say y squared is equal to x squared plus 1.4x, and then it'll be plus 49 and then minus 25. And on the other side, I'll have y squared is equal to x squared minus 16. All right, so on my left-hand side, I now have x squared plus 1.4x, and then 49 minus 25 is 24, so it's plus 24. So y squared is equal to that on the left-hand side, and then y squared is equal to x squared minus 16. Now, I can let y squared equal y squared. I'm just using substitution here, and I'm substituting for y squared. So wherever there's a y squared, I'm replacing it with, in one equation, I'm replacing it into the other, so that I get x squared plus 1.4x plus 24 is equal to x squared minus 16. Now, the x squareds cancel themselves out, and so we're left with 1.4x is equal sorry, 1.4x is equal to negative 16 minus 24. And the one small error that I made here was that when I did, I'm going to have to go back for a second, because this solution here was 0.49 minus 25. So I should have done 25 minus 0.49, which gave me 24.41. So I apologize. This was a 0.49 here, okay? So it should be giving me 24.41, and it's not a plus, but it's going to be a minus. Okay, so it's minus 24.41. So I need to change this. I'm just going to get rid of this last part here. So minus 24.41. Okay, so again, let me repeat. It was 0.49 minus 25, which when you subtract goes to 24.41. Now, making the two equations equal to each other, I get 1.4x is equal to negative 16 plus 24.41, and 24.41 subtracting 16 from that will give me 1.4x equaling 8.41. And now when I divide that by 1.4, so I have x equaling 8.41 divided by 1.4, I end up getting 6.01. X equaling 6.01 rounded to three significant figures, and that would be meters. So we know that the value of x has to be, or the not extended ladder, because remember, x is the not extended ladder, and it's going to be 6.01. Therefore, the extended ladder has to be, the extended ladder must be x plus 0.7, if I'm not mistaken. Let's just take a look at the diagram. Yep, it's x plus 0.7, because it's just 0.7 meters more. So it would be 6.01, 6.01 plus 0.7, and we end up with 6.71 meters. Okay, so we know that the extended ladder then now is 6.71 meters. Okay, and we know the other ladder is 6.0, not the other ladder, but the unextended version is 6.01. We know this is 5, and then the smaller version here is 4. So what we are being asked in Part B, so this was only Part A, what you're being asked now to complete in Part B is the increase in the angle that the ladder makes with the ground once the ladder has been extended. So what you need to do here is you definitely need to find the measure of both angles on the ground. So starting with the larger angle in green, I'm going to place that in green, and then the smaller angle, I'll put that in black. And you're going to have to do the subtraction of the two, so that I'll call the green angle theta, and then the black angle, I'll call that alpha. So let's find angle theta first. So theta is going to equal, let's see, it's opposite over hypotenuse. The opposite is 5. So it'll be opposite is going to be sine. So we'll say that the sine of theta is equal to the opposite 5 divided by 6.71. And then we'll do theta is equal to the sine inverse of 5 divided by 6.71. And when I work that out on the calculator, oops, open the wrong thing. When I do this on the calculator, I go to second function, sine. Remember, we want to find the angle measure. Second function, sine 5 divided by 6.71. Close the parentheses, enter, and we have 48.2. So theta is equal to 48. So it goes to 48.2. Sorry, my phone rang. All right. So the other angle that we're going to take a look at is going to be the smaller angle. And the smaller angle is going to be alpha. So with respect to alpha, we're going to do sine alpha is equal to 4 divided by x. X in this case was we had said it was 6.01. So it's 4 divided by 6.01. And when I place into the calculator second function sine of 4 divided by 6.01, I end up getting 41.7, which is 41.7. Now, the change in the measure of the angle, change in measure of angle, is going to be then 48.2 minus 41.7. So all I do is I subtract 48.2 minus 41.7, and we end up getting that there is a difference of 6.5 degrees. And that was our answer to part 2, or part B. This was 6.5 degrees, and up here our solution was 6.71 meters. Okay, we're done. I think that pretty much covers everything that we needed to look at for today. So you are to complete a number of word problems. And the more practice you do, the better it is. All right, see you next time.